In this lesson, we're going to discuss how to factor a perfect square trinomial. So by the end of this lesson, you should be able to factor trinomials that are perfect squares. Now, factoring a perfect square trinomial is going to be doing the reverse or the opposite or the inverse of factoring or of our special products. So if you recall, two of our special products were looking at the square of a sum and the square of a difference. Now, we don't want to mix these up with the difference of squares, which we talked about in the last two lessons. But we did talk about the square of a sum and the square of a difference and how they were shortcuts for FOIL. So remember that when we factored, or the a minus b squared, which is the square of a difference, factors to a minus b times a minus b. So that's expanded. And then when we FOILed it, we got a squared minus 2ab plus b squared. Now, as we FOILed it, we were like, hey, there's a shortcut here. The shortcut would be to get the first term, to get a squared, we would square the first term in the binomial. And to get the last term, we would square the last term in that binomial. And then to get this middle term, this 2ab, we said, hey, if I take a and b and I multiply them together, and I multiply that by 2, that will give us the middle term. And then if it was the square of a sum, it would be added. And if it was the square of a difference, then that middle term would be subtracted. And so when we're factoring perfect square trinomials, we're moving back from this form right here, the trinomial form, back into that special product. So a couple things that we need to kind of keep in mind. The first is, in order to identify a perfect square trinomial, 3 conditions must be met. The first term must be a perfect square. The last term must be a perfect square. So the first and the last term need to be perfect squares. And then the middle term needs to be twice the square root of both the first and the last term. In order for it to be a perfect square, it must meet those 3 requirements. One additional condition must be met, and that means that the last term, has to be added. So it must be positive. If it's subtracted, then it's not a perfect square, and you're going to have to factor it any of the other ways that we have. So once you've identified that it's a perfect square, again, this is going to be our shortcut for factoring. So look for a GCF. If there's a greatest common factor, you want to pull that out first. It may not start off as a perfect square trinomial, but after you pull out the greatest common factor, you see, hey, this is a perfect square trinomial. So to get that perfect square trinomial, to factor it, you're going to square root the first term, and then you're going to add it or subtract it to the square root of the last term. That middle sign is going to determine if you need to add or subtract in the middle. So, an a squared minus 2ab plus b squared, and this perfect square trinomial, when I factor it, I take the square root of the first term, so I take the square root of a squared, which is a, and I take the square root of b squared, which is b, and because this is a minus on the middle, this tells me that I need to subtract that, and so this is what we're going to have. We're going to have a minus b squared. Same thing is going to be true for the square of a sum for this perfect square trinomial, but because the middle term is being added, instead of subtracting the inside, I add on the inside. Let's take a look at one example real quick. So we have x squared plus 4x plus 4. This is a perfect square trinomial. The first term is a perfect square. The last term is a perfect square. And if I take the square root of x squared, that's x. If I take the square root of 4, that's 2. And then twice 2x is 4x, so that gives me that middle term. So when I'm factoring this one, I'm going to take the square root of the first term, and take the square root of the last term. And then because this is adding here, I'm going to add them, and it's going to be that binomial squared, so x plus 2 squared. Alright, let's look at a couple of examples. So, again, you want to determine if the trinomial is a perfect square. So if I look at x squared is a perfect square. So that factors, that square root of x squared is x. Square root of 36 is 6. So those are perfect squares. And then the middle term is twice 6 times x, which is 6x. So twice that is 12x. So I know that my middle term of 12x is 2 times my first and last term. So because I've identified this as being a perfect square, I'm going to get my binomial set up. It's going to be the same binomial squared. Take the square root of the first term, which we established was x, square root of the last term, which we said was 6, and it's either going to be addition or subtraction in the middle. Because it's a plus 12x, positive 12x, that means that I'm going to add in that binomial to give us 6. All right, we look at b. Again, the first term is a perfect square, so that would be 2n. The last term is a perfect square, so that would be 7. But this is not a perfect square because 2n times 7, if I double that, that does not give me 13. So this one would not be a perfect square, and so we'd have to factor this a different way. So the second one is not a perfect square. Looking at this next set of examples, again, we're going to factor completely. We're going to check to make sure that they're perfect squares first. So we're going to square root the first term, which in this case would be n. We're going to square root the last term, which in this case would be 4. And then I want to see if twice the first term and the last term give me 8n. So 2 times n times 4 does give me 8n, so I know that this is a perfect square. So because this is a perfect square, I know that it's going to be a binomial square. Because the middle term is subtraction, this inside part has to be subtraction. And to get the two terms, it's the first term, the square root of the first term, minus the square root of the last term. So that'd be n minus 4 squared. Again, FOIL to check. So n minus 4 times n minus 4. Is how that can be rewritten, and you could FOIL to check to make sure that you got the correct answer. So again, doing the same thing with b. Square root of the first term is 2p. The square root of the last term is 3r. And then, again, twice the first term, so twice 2p and 3r should give me 12r. Well, 2 times 2p is 4p, and 4p times 3r is 12pr. So we know that we're good here. So I know that, hey, this is going to be written as a binomial square because this term is adding. Addition needs to go on the front. And then the square root of my first term goes here. The square root of my last term goes here. And so we have 2p plus 3r squared. We do the same thing for the last one. So square root of 4a squared, which is 2a. Square root of 49, which is 7. Again, I want to check to see if I'm going to get the middle term. I can already tell you that 2 times 2 is 4, and 4 times 7 is 28. It does not give me negative 2a. So this is not a perfect square trinomial. It doesn't mean that it can't be factored necessarily. It just means that you can't factor it the way that we would every other perfect square trinomial. As we do look at this one a little bit further, though, we do see that this one would actually be prime as we go to factor it other ones. So looking at this next step, okay, before we factor, I noticed that the GCF between my three terms is greater than 1. So I'm going to factor that part out first, actually. So in this first one, the GCF of 2 I'm going to pull out, so it's going to give me 9x squared plus 6x plus 1. And now that I'm looking at this, I'm like, hey, I didn't initially see a perfect square trinomial, but now I do. So let me check it. Square root the first term, square root the last term, and see if, when I multiply those together and by 2, that gives me the middle term. And it does. And so, hey, I have my binomial squared. It's going to be adding because the middle term is addition. Take my first term squared, which is square root of my first term, square root of my last term. And then remember we pulled out a GCF. So because I pulled out this GCF of 2, I must include it as one of my factors. So we'll have 2 times 3x plus 1 squared. Again, do the same thing with b. My GCF for b is 3. So if I pull out a 3 from each of the terms, this becomes 4h squared minus 20h plus 25. Again, same thing. I didn't initially see it, but now we see that this is also a perfect square. So the square root of 4h squared would be 2h. Square root of 25 would be 5. Again, multiply those together and by 2 and see if you get 20. 2 times 2 is 4. 4 times 5 is 20. 20h. So we're good there. Again, because this is subtraction, when I go set up my binomial, I'm going to put subtraction in the middle. Square root of the first term minus the square root of the second term would give me 2h minus 5 squared. Again, we pulled out this GCF here, so my GCF would be 3. I'd have to write that as one of my factors. On 4, we have the volume of a rectangular prism is the polynomial that's shown. We want to find the dimensions. The dimensions are length times width times height, so they would be the factors of this polynomial. Because there are 4 terms here, we're going to factor this by grouping. So remember, anytime we have 4 or more terms, we factor by grouping. So I'm going to group the first 2 terms together, or group the last 2 terms together. I could group them differently. I'll still end up with the same answer. The GCF that comes out of the first term is x squared. So that leaves me with 2x plus 5. The GCF that comes out of the second group is negative 4. So that gives me positive 2x plus 5. Again, we want these 2 binomials to be the same. So when I rewrite it, that's going to be x squared minus 4, and then 2x plus 5. And if you notice, this is a difference of squares, which we talked about in the last video. So in the difference of squares, remember that it's the square root of the first term, square root of the last term. And you're going to write that as the product of a sum and a difference. Then we have 2x plus 5. So after we factor the difference of squares, we see that our 3 dimensions are 2x, or x plus 2, x minus 2, and 2x plus 5. This is how we factor perfect square trinomials.